So in this lecture, we want to talk about more on recursion. So first of all, we'll start with strings. So we have seen examples of using lists. We have seen examples where we were just using numbers. We have seen multiple examples in both of them. Now I want to solve a couple of problems which involve strings, and then we will get back to lists where we'll be doing merge sort, quick sort, and problems like those. Right? Perfect. So let's start with the problem related to strings. So the idea is, or I should say, the problem is that we are given a string, right? And you're given two characters. Let's say character A and character B. Right? So in Python, everything is a string, but I'm assuming these are single characters. Okay, perfect. So you have this string. You have to replace all the occurrences of A with B. So wherever you have A, you need to replace that with B. Okay, perfect. So we can do it iteratively, but I want to do it recursively again for the same reason, because now if you use it like solve this problem using recursion, you will get more comfortable with strings and recursion, and then later on when we are solving harder problems, it will be easier for you. Okay, so how should we do this? Now I have a string. I want to replace character A with character B. Okay, let's talk about the base case. Length 0. Do nothing, right? We can just simply return this original string that we get in case of length 0, which is the empty string. Okay, hypothesis. Our function can do this for L-1 sized strings, right? That's my hypothesis. Induction step. So now, given a string, I can assume I can call recursion on this part of string and things will work fine, right? Things will work fine. Okay. So my only work is this first character. I need to take care of this. So first of all, we need to remember that strings are immutable. So you cannot change this original string. You need to create new strings whenever you want to do any kind of change. Okay. So because strings are immutable, we will not be using the start index approach. We can use the start index approach, but it's not really required here because you will be creating so many new strings anyways. Okay. Because for the output also you need to create a new string. Perfect. So now, what I'll do is, I'll call on this part first, I'll get a smaller output, which I'm assuming will have all the occurrences of A changed by B. Then I will check, if this character is A, then I need to return this. If this character is not A, my original input's 0 character stays the same, and I need to attach smaller output string along with it. Right? So whatever changes smaller output has been done with respect to this, that stays either ways. Anyways, that's going to stay. Those changes are going to stay. Whether to change the first character or not, that depends upon if s of 0 equal A. In that case, I need to return this. Otherwise, I need to return this. So for example, if I have, let's say A is C and B is X, and you have D written here, then you just keep D as it is, and you attach D with smaller output, right? And you return that. That's what we need to do. Okay, let's quickly write this code. Perfect. So I'm writing replace char. I'm going to get a string. I'm going to get A and B. So this is what needs to be replaced with B. Okay. First of all, my base case, if length of S equal 0, return S. And we need to return the changed string. So we are returning the changed string. So if length is 0, we return the empty string itself. Perfect. What next? Now, irrespective of what is in the first character, we need to call for the smallest string. So small output is replace char. Second and third argument will stay the same. The first argument should be the smaller string, not the complete string, the smaller string. So I can do slicing to achieve that. So this is my smaller string that is going for small output. Okay. Now when you have the small output, what do you need to do next? You need to check if the first character needs to be changed. So if s of 0 equal A, if these strings are same, in that case, I need to return, instead of A, it needs to become B, right? So I need to return B plus small output. In case it is not A, I can't return S, right? So for example, C needs to be replaced with X. This is D, A, C, B, X, C, D, right? So now when I call small output, when I call replace character on small output, these are already replaced with X. So just because this is not C does not mean I can say else return S, because in that case I would return the original string, which will be incorrect. So I need to keep this character, but the changed output that I received from this call, I need to keep that changed output. Okay, so this, and I need to attach the 0th character here, and that's what we are going to do. So what do you need to do? You need to return s of 0 plus small output. Perfect. Let's check it. Let's take the same example that we have taken here. DAC DX CD, and I want to replace C with X. And that's what we wanted to get. That's the answer we wanted to get. Okay, just to check the edge cases, let's try on this. Perfect. There was no C, so no replacement. This works fine as well. This works fine as well. Everything seems to be working fine, and this is perfect. So seems like this is what the correct function is, and just make sure that you understand what exactly is going on, right? So strings are a little interesting because they are immutable, so you need to make sure that you are attaching, you're picking up parts from here and there and you're attaching them correctly. Okay, thank you.